Hello students, I am Ekta. In our daily life, we often deal with collections of objects like books, stamps, coins, etc. Set language is a mathematical way of representing a collection of objects. Why is this language so important? Why should mathematicians want to use this language? One reason is that everyday language is imprecise and can cause confusion. For example, if I write 1, 2, 3, what do the 3 dots at the end mean? You say, of course, they mean the list of natural numbers. What if I write 1, 2, 4, what comes next? It could be 7 and then 11 and so on. Can you say why? Or it could be continued as 8, 16 and so on. If we explicitly say the collection of numbers that are powers of 2, then we knew that the latter is meant. So, in general, when we are talking of collection of numbers, we may refer to some collection in some short form, but writing out the collection may be difficult. It is here that the language of sets is of help. In this class, let us study sets and their types. Learning outcomes. To describe and represent sets in different forms. To identify different types of sets. Keywords from this lesson. Set, empty set, singleton set, finite, infinite, equivalent set, universal set, subset, disjoint set, power set, proper set, proper subset and common element. For example, 16 students play only cricket, 18 students play only volleyball, and 3 students play both cricket and volleyball, while 2 students play neither cricket nor volleyball. A total of 39 students are there in a class. We can describe this pictorially as follows. What do these circles in the picture represent? They are collection of students who play games. We do not need to draw 39 students or even 39 symbols or use different colors to distinguish those who play cricket from those who play volleyball, etc. Simply calling the collections C and V is enough. We can talk of those in both C and V, in neither and one but not the other. This is the language of sets. A great deal of mathematics is written in this language and hence we are going to study it. Set. A set is a well-defined collection of objects. Here, well-defined collection of objects means that given a specific object, it must be possible for us to decide whether the object is an element of the given collection or not. The objects of set are called its members or elements. For example, the collection of all books in a district central library, the collection of all colors in a rainbow, the collection of prime numbers. Representation of a set. The collection of odd numbers can be described in many ways. The set of odd numbers is a fine description. We understand it well. It can be written as 1, 3, 5 and you know what I mean. Also, it can be said as the collection of all numbers x, where x is an odd number. All of them are equivalent and useful. A set can be represented in any one of the following three ways or forms: descriptive form, set builder form or rule form, roster form or tabular form. Descriptive form. In descriptive form, a set is described in words. For example, the set of all vowels in English alphabets, the set of whole numbers. Set builder form or rule form. In set builder form, all the elements are described by a rule. For example, A is equal to X. X is a vowel in English alphabets. B is equal to X. X is a whole number. Roster form or tabular form. A set can be described by listing all the elements of the set. For example, A is equal to A, E, I, O, U. B is equal to 0, 1, 2, 3. Example, write the set of letters of the following words in roster form: assessment, principal. Solution: assessment. A is equal to A, S, E, M and T. Principal: B is equal to P, R, I, N, C, A, L. Types of sets. There is a very special set of great interest, the empty collection. Why should one care about the empty collection? Consider the set of solution to the equation x square plus 1 is equal to 0. It has no elements at all in this set of real numbers. Also, consider all rectangles with one angle greater than 90 degrees. There is no such rectangle and hence this described an empty set. So, the empty set is important and interesting and deserves a special symbol too. Empty set or null set. A set consisting of no element is called the empty set or null set or void set. It is denoted by empty set or null set. For example, A is equal to X. X is an odd integer and divisible by 2. X is odd numbers, those are 1, 3, 5. This can be divided by 2. No. So, A is the empty set. This can be written as A is equal to null set or empty set. The set of all integers between 1 and 2. Here there are no integers between 1 and 2, so this is the empty set. Singleton set. A set which has only one element is called a singleton set. For example, A is equal to X, 3 less than X less than 5, X belongs to N, so X is equal to 4, there is only one element. B is equal to the set of all even prime numbers. 2 is the only even prime number, so there is only one element in this set. Finite set. A set with a finite number of elements is called a finite set. For example, the set of family members, the set of indoor-outdoor games you play. A is equal to x, x is a factor of 36. Infinite set. A set which is not finite is called an infinite set. For example, 5, 10, 15 and so on. The set of all points on a line. To discuss further the types of sets, we need to know the cardinality of sets. Equivalent sets. Two finite sets A and B are said to be equivalent if they contain the same number of elements. It is written as A similar to B. If A and B are equivalent sets, then n of A is equal to n of B. For example, consider A is equal to ball, bat and B is equal to history, geography. Here, A is equivalent to B because n of A is equal to n of B is equal to 2. Equal sets. Two sets are said to be equal if they contain exactly the same elements, otherwise they are said to be unequal. In other words, two sets A and B are said to be equal if every element of A is also an element of B. Every element of B is also an element of A. For example, consider the sets A is equal to 1, 2, 3, 4 and B is equal to 4, 2, 3, 1. Since A and B contain exactly the same elements, A and B are equal sets. Universal set. A universal set is a set which contains all the elements of all the sets under consideration and is usually denoted by U. For example, if we discuss about elements in natural numbers, then the universal set U is the set of all natural numbers. U is equal to x, x belongs to n. If A is equal to Earth, Mars, Jupiter, then the universal set U is the planet of the solar system. Subset. Let A and B be two sets if every element of A is also an element of B. Then A is called a subset of B. We write A subset of B. A subset B is read as A is a subset of B. If A is not a subset of B, we write A not subset B. Clearly, if A is a subset of B, then n of A less than or equal to n of B. Since every element of A is also an element of B, the set B must have at least as many elements as A. Thus, n of A less than or equal to n of B. The other way is also true. Suppose n of A greater than n of B. Then A has more elements than B and hence there is at least one element in A that cannot be in B. So, A is not a subset of B. For example, 1 is subset of 1, 2, 3. 2, 4 is not a subset of 1, 2, 3. Proper subset. Let A and B be two sets. If A is a subset of B and A not equal to B, then A is called a proper subset of B and we write A proper subset of B. For example, if A is equal to 1, 2, 5 and B is equal to 1, 2, 3, 4, 5, then A is a proper subset of B, that is, A is proper subset of B. Disjoint sets. Two sets A and B are said to be disjoint if they do not have common elements. In other words, if A intersection B is equal to null, then A and B are said to be disjoint sets. Example, verify whether A is equal to 20, 22, 23, 24 and B is equal to 25, 30, 40, 45 are disjoint sets. Solution: A is equal to 20, 22, 23, 24. B is equal to 25, 30, 40, 45. A intersection B is equal to 20, 22, 23, 24. Intersection 25, 30, 40, 45 is equal to null. Since A intersection B is equal to null, A and B are disjoint sets. Two sets A and B are said to be disjoint if they do not have common elements. Power set. The set of all subsets of set A is called the power set of A. It is denoted by P of A. For example, if A is equal to 2, 3, then find the power set of A. The subset of A are null 2, 3, 2, 3. The power set of A. P of A is equal to null 2, 3, 2, 3. Points to remember. A set is a well-defined collection of objects. Sets are represented in three forms: descriptive form, set builder form, roster form. If every element of A is also an element of B, then A is called a subset of B. If A subset of B and A not equal to B, then A is a proper subset of B. The power set of the set A is the set of all the subsets of A and it is denoted by P of A. The number of subsets of set with m element is 2 power m. The number of proper subsets of a set with m elements is 2 power m minus 1. If A intersection B is equal to null, then A and B are disjoint sets. If A intersection B not equal to null, then A and B are overlapping. Thanks for watching. Like, share and subscribe.